A collision happens when two objects come into contact with each other while moving, but not all collisions are the same. Some objects bounce back while others stick together or lose energy. That's where we get our two types, the elastic and inelastic collisions. In an elastic collision, two objects collide and then bounce off each other. The key here is that no kinetic energy is lost in the process. That means if we measure the total kinetic energy of the objects before and after the collision, it remains the same. That's because the forces involved are completely reversible, so there's no energy lost to sound, heat, or deformation. But wait, just because kinetic energy is conserved, does that mean objects always return to their original speeds? Not always. In a truly perfect elastic collision, this would happen, but in reality, we don't see perfectly elastic collisions, often because small amounts of energy can still be lost to things like air resistance and friction.
So let's talk about inelastic collisions. Unlike elastic collisions, where objects bounce off each other, an inelastic collision is when two objects collide and stick together, becoming one mass and moving together. Unlike elastic collisions, these do not conserve kinetic energy. Why? Because some of that energy is lost often as heat, sound, or deformation. Now, in a perfectly inelastic collision, when this block hits the other block, it will stick together and move as one object, but they move as one mass at a lower speed. Now, let's look at an inelastic collision in real life. In a car crash, the front of the car crumples. This isn't just bad luck though. It's actually designed on purpose to protect passengers. See the dent? That's a great example of an inelastic collision. The trash can absorb the energy from the impact just like a car's crumple zone absorbs energy in a crash while the two objects still moved as one mass.